Hello students, and welcome to this unit on graphing circles. This unit is going to be very quick. It only has one lesson to it. So let's get started. We are working on the equation of a circle and how it relates to a graph. We're very lucky that this is one equation that the SOL gives us. It's on our formula sheet. So let's jot it down here so we have it while we're doing our notes. The equation is, in parentheses, x minus h, end parenthesis, squared, plus parenthesis, y minus k, end parenthesis, squared, equals r squared. Now I realize this is a whole bunch of letters, okay? But remember, we're working on a circle. So the two pieces of the circle that are represented in this equation are the center and the radius. The h and k work together to represent the center point, and the r represents the length of the radius. So I have several examples here. I'm going to do a bunch with you, and then I'm going to let you do some on your own and check your work. When I'm writing out the equation of a circle, the first thing I like to do is just write out the shell based on what's given to me in the formula sheet. Here's what I mean. I know I'm going to be putting in the h, the k, and the r. So I write out everything except the h, the k, and the r. I'm getting the h and the k and the r from what's being given to me in the problem. Here, they're giving me 5, 3 as the hk, and they're giving me a radius of 2. So instead of x minus h in parentheses, I've got x minus 5 because 5 is representing the h. Instead of y minus k in parentheses, I've got y minus 3 because 3 is representing the k. And instead of r squared, I'm plugging in a 2 because 2 is representing the radius. Now, the only thing in this entire equation that might be simplified down would be this 2 squared. When you square something, you multiply it by itself. So this would be 2 times itself, which is 4. All right, let's try example 3. I'm going to do the odds and let you try the evens. First things first, I write out the shell of my equation. X minus whatever h is going to be squared plus y minus whatever k is going to be squared equals my radius squared. Well, I'm looking at what I've been given here, and in this example, I'm giving h as -2, k as -11, and the diameter is 18, so I have to stop a minute and think about what the radius would be. Well, remember, a diameter is all the way across the circle through the center. So 1 diameter is equal to 2 radii. So if I take 18 and divide it by 2, it gives me 9 for the radius. Now when I plug everything in, here's what it would look like. X minus h, and this h is a -2, y minus k, and k is -11, and the radius, which is 9 squared. This time when I simplify my work, there are 2 things to simplify. I need to simplify these double negatives. X minus -2 could be simply written as x plus 2. Y minus -11 could be written as y plus 11. And 9 squared, which is 9 times itself, or 9 times 9, is 81. All right, let's look at example 5 together. In example 5, the h is represented by a -4. The k is represented by a 0, and the radius is represented by the square root of 47. I want to talk about what's going to happen when the k value is represented by a 0. If we use the parenthesis, y minus the k value of 0 squared, we've really written something that's completely unnecessary. We don't need to write a variable minus 0. Any number minus 0 is simply that number. So y minus 0 squared is it's too busy. It can be very easily written as y squared, and then we would understand that there's a 0 there. So when I go over here to write out my formula this time, I am not going to open up a set of parentheses for the y value because there is no k to attach to that y value. When I plug in the h value of -4, I get x minus -4 squared plus y squared. And then when I plug in the radius of the square root of 14, I get the square root of 14 squared. So I have two things to simplify again. I've got a double negative here. X minus -4 could simply be written as x plus 4. The negatives form a positive. And here, a square of a square root is an inverse. Square roots and squares are inverses of each other, so they just cancel each other out. So what simplifies here is just 47. I'm going to pause the video and I want you to take a few moments and see if you can do the evens on your own. Check as you go. I've written my final answer for number 2. Let's talk it out a moment. If the h value is a -1, but the formula has x minus in it, that minus, along with this negative on the 1, simplifies to a +1. Then I've got y minus 7 because the minus sign is built into the formula, and the 7 represents the k value. The radius is 14, so I took a moment and did 14 squared and got 196. So this is my final simplified answer for number 2. Give number 4 a try. I've written my final equation for example number 4. In this equation, the x value would be attached to a 0. So x minus 0 is unnecessary to write. I can just write it as x squared. Y minus 9 represents the k value. And here you've got to be careful. You're given the radius in a sneaky way. The diameter is listed as 32. So if I cut the diameter in half, that makes 16 for the radius. So 16 squared is 256. Your last example is number 6. Give it a shot. Finally, we're looking at example 6. I've got my answer here so you can check. In example number 6, the h value given to me is a positive 15. So when I plug it into the formula, the x and the minus sign come from the formula. The 15 represents that positive h. Then a squared, then the plus sign, and a new set of parentheses. Here I'm doing y minus k, and the k value is -6. So when I think of y minus a negative k, I know that that's going to simplify to a +6. And finally, my r value is listed as the square root of 158. So remember, when you square something with a square root on it, the square and the square root cancel away. So I was left with just 158. Next, we're going to write up the equation of a circle, but the given information is very much disguised. It's disguised in a graph. So let's check this out here. if you're given a graph of a circle and you have to write up its equation, you're still searching for the same two pieces, the center and the radius. Well, these are things that you can count from the graph. First, let's find the center. The center is at the point x value of 3, y value of -2. That makes my h value 3 and my k value -2. Now, to find the radius, I would do this the easiest way possible, which is to just count. Remember, a radius is the distance from the center to the edge of the circle. By counting a horizontal distance or even a vertical distance, I'm making this really easy on myself. It would be very difficult. I'd add an extra layer of difficulty in if I tried to count diagonally. So I'm going to count horizontally. 1, 2, 3, 4, 5 blocks. If you counted vertically instead, it's still 5 blocks because the radius of a circle is the same in any direction. So the radius is 5. Now I can piece together the equation of this circle. X minus h squared plus y minus k squared equals r squared. Here, the h value is a positive 3. The k value is a -2, so that's going to leave me with minus a negative, and the radius is 5. The two things to simplify are the double negative in the y set of parentheses and the 5 squared. When simplified, this equation would read x minus 3 squared plus y plus 2 squared equals 25. Okay, our final layer of difficulty is going to be presented this way. Instead of giving us the center and the radius, here in our first layer of difficulty, they just told us the center and the radius. Here they kind of hid it within the graph, but we could count out the center and the radius. And here on this final example, they give us the center still, so there's the h and k we're looking for, but they give us no radius. So what I would suggest if you are a visual person, then I would suggest working on a graph. Let's take a peek. If I plot this 9, 10, there's the center to my circle. The other point that is given to me is the point 7, 4. So if this is the center of my circle and this is the random point, that means my circle is going to look something like this. I'm not going to be very good at freehand drawing a circle. It's pretty wonky looking. It's going to look something like that. So really what they've given me here is the radius. The distance between the center and the random point on the circle is the radius. Now, you heard the right word. I said distance. So I think I'm just going to use my distance formula and make it very simple. Distance formula. Distance is equal to x minus x squared plus y minus y squared. One of the x's is 9, the other is 7. One of the y's is 10, the other is 4. At this point, I could grab my calculator or I could keep going doing this work in my head. 9 minus 7 is 2, and 2 squared is 4. 10 take away 4 is 6, and 6 squared is 36. Combine the two, and I get the square root of 40. Now remember, all of this work was to represent the radius. The distance between the 2 points was to represent the radius, which is now our r value in our formula. So now when I put all this together, x minus the center, h value is 9, y minus the center, k value is 10, equals the radius squared. So I'm going to be squaring a square root. When you square a square root, the square root and square cancel each other out. So I'm going just to get 40. For the second example, I did not provide a graph that was big enough. The center is at 1, -5. The random point is way out at -7, -13. So instead, I'm just going to work this without a visual and work on the radius. The distance from the center to the point is the radius. So I'm going to use my distance formula, x minus x squared plus y minus y squared. I'm going to plug in my x values of +1 and -7, y values -5 and -13, and simplify. 1 minus -7, there's another double negative, so plus a positive makes 8, and 8 squared is 64. -5 minus -13, which is plus 13, is 8 again, and another 8 squared is 64. 64 plus 64 is 128. Remember, this is representing the radius. It's the distance between a point on the circle to the center. Now I can put together my formula. X minus the h value of 1 squared plus y minus the h value of -5. So minus a negative is plus a positive. Squared equals my radius squared, and here the radius squared would be a square root being squared. It would drop off that square root sign and leave me with 128. Okay, guys, as we worked through this notes, we started with the easiest, where everything is handed to you and all you have to do is plug it in the formula. Moved on to a medium example where you would have to find the center and radius out of the graph to plug into the formula, and finished with the toughest example where you're going to have to pull something from the past that we've learned, the distance formula, to find the length of the radius to plug into the formula. Happy studying!